Hello and welcome to the last video of Introduction to Data Science. So we're going to be wrapping up the course with this video. So I wanted to first briefly look over what did you learn this semester. We started with introduction to all of the toolkit that we're going to be using in this course. So you've learned about using R as a programming language, or Studio as the integrated development environment where we do our computing. And you've also learned about version control with Git and using GitHub as a web hosting service and also for collaboration. And we covered a lot of this stuff and did an introduction to them in the first week. Then we visualized data, wrangled and tidied data, imported data, recoded data, and finally kind of wrapped all of this together, this data in a data exploration unit that we titled Communicating Data Science Results Effectively, where we reviewed a bunch of the material that we had learned up to that point, but then also talked about how to structure a project and how to style your code. We then went into a little bit of programming and web scraping and had a week on data science ethics. And then we went into our modeling unit where we started by introducing what models are, how to build models for predicting numerical and categorical data, and with the categorical data, how to do classification. Then we talked about model validation with cross-validation and estimating uncertainty with bootstrapping. And finally, this week, we talked about a bunch of topics that you requested, which were text analysis, developing interactive web apps, and machine learning. And this week's videos were very short compared to what it would take to really communicate each of these topics kind of in depth, but hopefully they provided a nice kind of introduction to the topics where maybe in the future you'll take some courses or do some self-learning to get deeper into them. Well, as you were doing these, what did I learn? Well, this was actually where I was recording much of my videos, this like green screen setup. So I learned to do how to videos, and I learned how to edit videos. We had a few mishaps for a few of these them at the beginning, but I think after that we got into a good cadence, and hopefully you enjoyed them. I know that it hasn't been the same experience that it would have been if we were in person in class together, but we tried to make the best of it as much as we can. And I wouldn't call myself a video expert in any way, and I don't even know if I enjoy making them so much, but I've certainly gotten better at them over the semester. Then we asked you, what are some questions that you'd like to get answers on? So one of you asked, what kind of research might someone do in the field of data science? And the answer to this question really is so vast. But what I wanted to do was to give you one example. So this is just one example from one research group from the Turing Institute. They have, at the link that I have here, their data science projects. So these are the research agendas of folks affiliated with the Turing Institute. But let's take a look at a couple of these topics. We have, for example, masking clouds and satellite imagery, diffuse multiple scattering analysis, data science for climate resilience in East Africa. Very different topics if you think about it. So these are more like environmental based topics that we're looking at, which tend to be the things that don't necessarily first come to mind when we think about data science research. Obviously, lots and lots of research nowadays on the area of artificial intelligence and machine learning fall into data science. And so the amount of the different venues of research that tend to be very interdisciplinary. I think that's really one theme that you're seeing here, that the data perhaps comes from another discipline, but then the analysis of the data and how we draw inferences from that data requires a lot of data science skills. Sometimes these are modeling skills, sometimes these are statistical skills, and sometimes before we get into the statistics and the modeling, there's a lot of curating of the data, bringing data from various sources together and putting it into a format where one can then model to kind of glean results from that. So all of that really falls into this. I encourage you to just browse through. This is one of the 6 or so pages of these little thumbnails of different projects they have, and then if you click on any one of them you can read a bit more about them, and really you can think about doing the same sort of a Google search for like data science, University of Edinburgh, or any other university that you might think of, and also put the research next to it to see what are some of the topics that come up, to get a better sense of what are the various types of research that people are doing in this area. Another question asked, and I think this was a difficult question to answer, so I'm going to dodge it. I'll let you know ahead of time that before the U.S. election, the polls indicated that Biden will win by a landslide, but after the results, it was not as big as polls suggested. Is there a reason why this happens? Should we rely on polls before election? So a little bit difficult of a question to answer because we're kind of now that actually it has been a while since the election, and many more of the states have finalized their voting results, we're actually seeing that the difference wasn't that tiny after all. But initially, it seemed like many states, as the counting was happening, it was kind of unclear where things were going to go. And the whole, the fact that we're not necessarily talking about the popular vote in the US, but the Electoral College really makes it harder to wrap our heads around exactly what is happening in terms of public opinion. But what is happening with the polls? There are a few ways polls, can go wrong. Sometimes this might be due to sampling bias, but a lot of the polling agencies have good measures against this. There is also the effect of people not necessarily perhaps being honest about what they are suggesting they might do. So there's a little bit of that as well. But ultimately, when we think about were the polls correct, we for any estimate that we report, there is some uncertainty around that. So this notion of were they correct really is not just about the estimate that they reported, but the margin of error around that. And if you actually look at the margin of errors, many of the predictions were still in the right ballpark, even if they weren't spot on with their predicted estimates. I would recommend, if you want to find out more about this, Andrew Gelman, who's a statistician at Columbia University, has a really nice blog. Him and a few others write the blog, so not just him, but he does have many. He has written many posts about this because he was working with The Economist on their election forecasting model. So this particular blog post comparing election outcomes to our forecast and to the previous election, really in that image you can see kind of those margin of errors around the estimates that we were talking about, and how kind of they did in terms of capturing the true value. And so this is a great post to read through if you're interested in this. Now, another post from the same blog that I would also recommend along with this was by Jessica Holman, called Can We Stop Talking About How We're Better Off Without Election Forecasting? I think this was an interesting read, because I think whenever it feels like people are getting the stats wrong, the first reaction often tends to be, oh, maybe we shouldn't do any statistics at all. But actually, we learn a lot from these. In terms of how the polls did, they had done pretty poorly in 2016, and then some things did get better. So we learn about how to adjust for these things. So I don't think necessarily that the solution to, so this notion of are we better off without them, I don't think that answer to that is as clear cut. And I would say as a statistician that we're probably not better off without them, but we clearly need to be very careful about them. Another thing that is super, super important to acknowledge here is that the polls themselves can have an impact on human behavior. When people think something is going to happen anyway, do I really need to get out and vote? So I think that we really need to be cognizant about not just the statistics and the modeling, but also the communication of these results. And communicating uncertainty is a notoriously difficult task. And many data journalists have been doing a fantastic job about this, but we still have a long ways to go until we can really communicate this sort of stuff. And this is not just in the context of elections and polling either. I think we're seeing a lot of these issues with our reporting around COVID numbers, and more recently with this notion of the efficacy, for example, of the vaccines that are coming out, that there's always this uncertainty around the measurements that are being quoted, and oftentimes we don't hear the uncertainty around them, but we only hear the estimates, because it does tend to be a little bit difficult to wrap our heads around. Another question was, which area can I use R in my future? Well, many areas. So I tried to give an empirical answer to this, and one answer I found that I thought was a nice visualization was is actually from 3 years ago, but I don't necessarily think that this trend, the heights of the bars might have changed, but I don't think the like the axis labels, as in the various areas, would have changed so much over the 3 years. So this is based on data on Stack Overflow, which you probably have landed on once or twice if you were Googling R or any sort of programming related things. And so this is a visits to R by industry, so if they can track who you are based on your account, if you have an account with them. And we can see that academic is a huge component. We've talked about how R is a statistical programming language, so it makes sense that it was born out of academia and that it's very heavily used in academia. But when we think about academia, it is not just statisticians that use R. Many other disciplines that do any sort of quantitative research, be it political science, biology, genomics, whatever, all, use R as one of the tools they use as well, even if not the only tool. Healthcare comes up a lot. So here we're perhaps thinking about pharmaceutical companies or life sciences companies. Government also comes up a lot. Many government agencies use R. I happen to know that here in Scotland, for example, the quantitative groups within the NHS are really heavy R users. Insurance is another industry that does. Energy, finance, retail, media, manufacturing, tech, and electronics. So we're seeing a variety of areas that use R as part of their quantitative work. For any, if not all of these areas, R is probably not the only thing they are using, but many of these industries choose to use R for data wrangling and data exploration and data visualization, and many also for reporting as well. When it comes to modeling, depending on the types of models you're using, and depending on the industry and kind of the traditions in that industry in terms of like how people have been educated, you might see people using R-based tools or Python-based tools. Another question was, how can I improve my data science skills on my own? Any recommendations for websites, books, etc.? So we have read many chapters from the R for Data Science book, but we certainly have not finished it. So there is more in that book that I would very strongly recommend, that if you're wanting to dive further into R, that would be a good book to basically finish cover to cover. Maybe except for the modeling section, because I'll make another recommendation for that, but that's just one of the chapters. But the rest of it, chock full of good information, and definitely information that anybody coming out of this course will be able to consume and learn from with no problem whatsoever. The next step really varies on what you want to do next. So if you are interested in R as a programming language and you want to learn more about programming with R, I would recommend the Advanced R book, also by Hadley Wickham. If you are interested in more of the modeling stuff that we've done and would like to dive further into it, there's a book that's in progress. So you'll see that some of the chapters as of today are not complete, but there is a lot in there. Is Tidy Modeling with R, and again, I think we have done a couple sections of reading from there by Max Kuhn and Julia Silge. So these are people who work on the Tidy Model suite of packages as well. And so I would very strongly recommend, either both of these as books, but especially depending on your interest of more programming or more modeling, going into one of these. So I think those would be good next steps after you're done with R for Data Science. We are all aware of Tidy Tuesday. I haven't even put the link here because I think we all know how to find that information. We've done so many of our code alongs with Tidy Tuesday datasets, and many of you are using datasets from that for your projects. So I would recommend keeping up with it. Every Monday there's a new dataset released, and every Tuesday people share their visualizations or tables, whatever they make with that dataset, on Twitter under the Tidy Tuesday hashtag. So I would recommend keeping up with that, and actually doing a little bit with participating in that activity as well. A mailing list / website that either you might want to visit or subscribe to is R Weekly. So you can actually subscribe there for a weekly email to be delivered to your inbox, or they have, I think, an RSS feed, or you can go and read it there. But you can see kind of on the side the types of highlights that they do on a weekly basis. Examples from blog posts from R in the real world, R in organizations, R in education. They also talk about new packages and updated packages, any sort of videos or podcasts, people's Shiny apps, tutorials, events, so on and so forth. So I think it's a really nice digest. They certainly don't spam, so I wouldn't worry about that. It is one weekly email that comes through. I find it really delightful to kind of browse through it and see if there's anything else I want to dive further into and read a couple blog posts. And even if I don't, it's useful to know, somebody did this, so next time I need that sort of thing, I know that there was at least a blog post out in the ether about it that I can go back and visit. Another question was, and multiple people asked versions of this question, so I just captured one of them here. I really enjoy taking data science this semester. That's great. Are there any other courses I can take semester 2 or next year that develop on what we've been learning? I think my answer is yes, absolutely. There are courses that develop on what we've been learning, even if they have not been designed to follow on from this course. So in year 2, there is a statistics course that will pick up in terms of this uncertainty quantification we've talked about with estimation and bootstrapping. So more of this sort of interval estimation, hypothesis testing, and also more regression sort of analysis will be covered there. So I would recommend that course in year 2. If you're interested in more of the computing side of things, so statistical computing side of things, which we've dabbled in a little bit when we were learning web scraping, where we learned to write functions and stuff, but then we didn't actually go further down that path so much in this course. The statistical computing course that you can take in year 3 would be a great choice for that. There's also a year 4 course called statistical learning, where you're going to be learning more about machine learning and deep learning and other sorts of kind of machine learning models. So that would be another course. So these are obviously years out as opposed to coming up right after what we've learned, but I've given suggestions in year 2, 3, and 4 for those. There's also another course in informatics that might be of interest. So this is a year 1 course called Cognitive Science. The course description is quite long, but you'll see that there is some text analysis stuff there and a little bit of machine learning-y stuff in there as well, and working with larger data sets that might be of interest to folks coming out of this class. Other things is kind of outside of the class learning. You could be working on various projects. So I'll here give a link. So if you open up the PDF slides, you'll see that the Center for Statistics recently wrote about a project I worked on with 2 students who took this course last year. And we actually developed the interactive tutorials that you've been working throughout the year. So those were developed by students who have taken the Intro Data Science course along with me. So if you're working on projects similar to those, reach out to me and we can see what we can find in semester 2. If you happen to have the time to take on something like that, we could try to come up with an idea, and it doesn't have to be interactive tutorials. It could be something else as well. I also want to draw your attention to an event we're on that I hope we'll be able to run again in the spring called Data Fest. So this is a weekend-long data analysis hackathon, if you will, or a data science hackathon. And the point of Data Fest really is about community building and being together as well, but we had to obviously do it virtually. Last year, lockdown happened right around the time we were supposed to have the event. This year, it's looking like even if we were to hold this event in March or April, it's probably not going to potentially happen in person. I don't really know, but the whole point was to gather in a room and work on this in kind of a high-paced environment. But if it doesn't, we are still planning on doing it online. So check back at that website, bit.ly/df-edi for Edinburgh Data Fest. And I think there are also lots of student organizations who are kind of interested in tracking down what other sorts of hackathons and whatnot are happening around town. Many of them are happening virtually right now, but they're still happening. So if one option to continue learning is working on a structured project, and another option is to get involved with activities like this. So thank you all for sticking with it throughout the semester. And thank you to those of you who have answered questions on Piazza and asked questions on Piazza. We are going to have the Piazza Awards that I had promised. I won't announce them here in this video, but I will send an email out with those who have contributed the most. And I'm very much looking forward to hearing your projects this Friday and probably throughout the weekend as well, as I watch the pre-recorded ones as well. I hope you've all enjoyed the course, and I hope you've been able to get the most out of it that you wanted to. I know that it's been a really challenging semester for all of us, and it is possible that you were interested in some of the topics and ultimately perhaps some things fell wayside. If you feel like there's things that you'd like to catch up on, either over the break or later, the introds.org website will continue to stay there. If at some point I update the course for the next year, I will still have a link to this year's course, so you can always come back. The course videos are going to remain on YouTube on Media Hopper, so if you're interested in catching up with things after the course is over, even though we won't have the staff support for it, the materials will still be there, and I'm always happy to hear from all students. So if you have minor questions here or there, always feel free to reach out to me. And have a good rest of the week, and very good luck with your exams and everything else coming up in the next few weeks. And I hope everyone has a peaceful break.